How's it going, everybody? In this video, we're going to take a look at our next topic in our SD-WAN series, which is going to be Application Aware Routing, or AAR. And this is actually a pretty cool feature and capability that you normally are not going to see on a regular Cisco router. It's not that it's not there, it's just difficult to actually demonstrate and then verify that it's actually working unless you actually have the applications available to you to play with. So we're going to look at a couple different variations here. The first variation we're going to look at is going to be using just layer 3, layer 4 mappings. So basically, we're going to be taking a look at, more specifically, layer 4. What the protocol is, so TCP and UDP, and then the actual destination that you're trying to reach. So we'll match on a protocol, so TCP, and then a destination port, a well-known port, like, for example, Telnet or Web, so port 23 or port 80. These are things that we can actually demonstrate and stuff like that. The only drawback to it is when you actually go to demo some of these features and capabilities, they don't work quite the way you want them to. So it's not like you can do a trace route and verify that particular traffic flow is going the direction you want it to go. So what we're going to do instead is we're going to take advantage of this guy right here. We're going to bring over vManage. I'm going to go over here to monitor and then network. And what I'm going to do is I'm going to grab one of these vEdges. vEdge 3 is what we're going to demo this on. And if you scroll down here to troubleshooting and you click on simulate flows over here. Okay. Now I'm going to select the VPN that I want to do this in. I'm going to create select VPN1, and the IP address we're going to grab, this is going to be the source IP, so the interface IP. The destination, I'm going to choose 10.1.0.16, which happens to be switch 16's loopback 0, something I could reach via the overlay. Now the application, you could choose a particular application here. We're not going to do that, but if you wanted to, you could. What I'm going to do is I'm going to click on advanced options, and then the service, so the traffic is going to be coming from the service. So this is basically is outbound towards the fabric. Tunnel means it's coming inbound from the fabric over the SD-WAN tunnel. I'm going to choose the protocol of 6, which is TCP. The source port could be anything random, so I'm going to just choose 2000. The destination port will be 23, so Telnet, right? I'm going to click on Simulate Flows. And you can see that it chooses to go out both public internet and MPLS towards vEdge 1 and vEdge 2. So what this basically means for us is that we know that the traffic will take a particular path. It'll go out the both T-locks towards the HQ site, which is what we wanted to do, right? Now, what I'm going to go do, I'm going to go ahead and update this to be port 80 and do the same thing. Simulate flows. It's going to go look at the routing table and go, okay, this is how this is going to work for port 80. The destination doesn't need to be enabled for web. It just needs to be allowed to send web. So the local vEdge is going to do some looking in it and say, okay, is there a reason why I can't? There's nothing restricting it, so it should be able to go. So I'm going to go over here to policies, and I'm going to go ahead and create a policy. So I'm going to do this. I've seen some other instructors do it where they create everything over here first. I can do the same thing by clicking on add policy, and then all of my groups of interest are over here on the left. So I'm going to go ahead and talk about some of the ones we need. We need a VPN, right? So I've already got the VPNs created, so I'm not going to spend a ton of time here. So we need whichever VPNs we want to apply this to. So yes, you could create VPN-specific topology. So if you want VPN1 to do something and VPN100 to do something else, you can do that. Site lists. I have all of my sites added here for this. I'm actually going to get rid of firewall needed because service chaining has not worked out yet for me. But we'll talk. Well, that'll be, if I can get that to work, I will circle back and cover that. Now the other one we have to go do is going to be the SLA class. Now I've got a few created already, and I'm going to walk you through basically how this works. So I'm going to go ahead and get rid of them real quick, just so you guys can see that this was working. I did test this already, so it does work. I'm going to go ahead and get rid of them. I'm going to create a new SLA class. Now I'm not going to get into the specifics of what all the metrics are because they're pretty obvious. I'm going to call this the Telnet class, and loss if something happens that the connectivity is causing you a certain percentage of loss. Let's say 25%, right? So you're losing a quarter of your Telnet packets are getting dropped, for example. Really high latency, we're just going to say 500, and we'll put in 250 for our jitter. Okay, we're going to create that. So in the event that any of these variables kick into play, you're going to be offered a failover, but prefer something else. And we'll talk about that where, for example, Telnet will take the MPLS path, right? We'll set that up because that's going to be something you're going to use internally. But web traffic, for example, you might have it steer out towards public internet and stay that route and only take public internet. We'll talk about some of those more details, some of those aspects of it later on, but you can pick and choose what you're doing. But before you can do that, as long as these variables are in spec, so you haven't exceeded any of these thresholds, then you're going to stay on the preferred path that you want it to go. If they bug out, they go above these thresholds, 50% loss, 100% latency, or 500 milliseconds of latency, and we'll say 300 milliseconds in jitter, so which is the variation in delay. If any of those variables go out of spec, out of threshold, then you'll say, okay, maybe MPLS isn't the best path, so let me go ahead and send that over to internet. We'll talk about that, how that comes into play here in just a minute. I'm going to click on add, and then I'm going to, these variables that I'm using here are just 100% random. There's no rhyme or reason for them. I just happen to take that. So for web, we'll say 10% loss. We'll say 150 milliseconds of latency, and we'll say 200 milliseconds in jitter. We'll add that. I'm going to go click on next. And now we need to go beyond here, right? This is if we're trying to do traffic control. We're not trying to do that. We're trying to go into traffic rules to affect the data plane. So underneath this guy, we need to click on add policy. So create new. And I'm going to call this AAR for telnet and web. Something very, very simple, right? Now, in order for this to work, I have to add a sequence type, which is going to be obviously application aware routing. I'm going to add a sequence rule. And in the match, I'm going to match on the protocol. So this is going to be basically a layer 4 match. I'm going to come into layer 4 or protocol. I'm going to match on protocol 6, which is TCP, and then the destination port will be 23. And underneath the actions, there is no drop here. We are going to say the SLA class list. So we already created that. We're going to say telnet. And then what we're going to go do is in the preferred color, we're going to click down here and we're going to say MPLS. Now you'd see this strict option right here. If you use strict, if you click on strict, you're only going to allow traffic to flow over, telnet traffic to flow over MPLS and not allow it to fail over to internet. Because you obviously will, internet is, I should say when I say that, you're going to prefer the T-lock routing over MPLS, right? So which is going to be the MPLS color. But if MPLS is really, really bad, very, very sluggish, and a lot of degradation on the network, if you click on strict, you will not allow telnet traffic to ride over the public internet T-lock. It's going to just use internet as the underlying transport when it goes over the SD-WAN fabric to the remote sites. So if you click strict, just remember that it's basically the same concept as restrict on the color, to where you're only going to form a BFD session with other WAN edges on that same color. You won't try to do cross transport communication. So just keep that in mind. We'll talk about that here in a little bit later. I'm going to go save a match and continue. And I'm going to click this little copy icon there. I'm going to go ahead and edit. I'm going to change this to be port 80. And the class will be web. And I'm going to change the color to be public internet. So it's going to ride the public internet T-lock. And there we go. I'm going to click on save match and continue. And in default action, make sure that it's set to enable and you didn't put some other variable in there. I'm going to save AAR policy. Then I'm going to click on next to the policy itself. I'm going to click in here. Well, that's supposed to be web, not when. I can actually rename it real quick. Let me go ahead and edit that real quick because that's going to bother me. Let's just change that to web real quick because that's going to make more sense. It's not applied yet, so we don't have to really worry about it. Come over here, web-policy, and copy and paste that right here. And under, we have to click on AAR, Application Aware Routing. And click over here, and then we have to dictate the sites, and so which site and which VPNs do we want to affect to this. I am going to affect VPN1 here, and you can choose, you can put them in any order. Do this, and then click on here. We're going to choose to do VH4 and VH3. So basically our WAN edges that have two actual TLOCs associated to it, the public internet and MPLS. I'm not going to try to throw a policy at VH5 which only has MPLS transport. It doesn't make sense to do that. The idea here is to be able to fail over an application to a different transport if one transport is really, really bad. We've all been there, right? So I'm going to go ahead and click on save, or click add, and then click save policy. Okay, so we're going to go click on this guy right here, and you notice all these other ones are activated. It says false, which means they're not activated. I'm going to click here and click on activate, and click activate one more time. Going to give it a couple seconds. This is actually pretty quick because of the fact that it's a control policy, and once that pushes down to the remote, the WAN edges will be in good shape. So I'm probably not going to need to pause. There it goes. Now I'm going to go back over here to monitor and network. I'm going to grab VH3. I'm going to go back down to troubleshooting, and I'm going to go to simulate flows. I'm going to choose VPN1, and then gig 0/2 and VPN1. The destination IP 10.1.0.16. And then advanced options, protocol 6 from service, because this is going to be coming in from this is inbound to go over the SD-WAN fabric. 2000 is my destination, my source port, and port 23 as my destination port. So simulate flow. And there you go. I'm writing over MPLS. Before I had showed both. Okay. Now I'm going to change this to be port 80 and click on simulate flow. And it shows public internet. So right there, ladies and gentlemen, shows you that our application aware routing is working. I can't demo this because it's not going to work the way we need it to, because it's this way here. It's application specific. If I was to try to telnet, I could like put some filters in and try to like say, okay, do we see traffic flying over this particular TLOC? Do we see traffic flying over this particular TLOC? In this case here, the nice thing about this is we get to see what vManage sees. So the vManage is actually reaching out to the VH saying, hey, what happens now? And the VH is going, well, based off your policy, this is what can happen. So we're in good shape there. Now with that being said, I'm going to go ahead and change this up a little bit. I'm going to go and we're going to take this a little bit deeper, because right now we've only done layer 3, layer 4. Well, more specifically layer 4. We looked at TCP, we looked at and we've looked at the protocol and the port, right? We have not looking at any deep packet inspection or DPI. So we haven't leveraged NBAR to do anything right now. So this is one of those times where you might want to go deeper. So let's go actually take a look at this. I'm going to go back over here to policies, and I'm going to click on this guy and go to traffic policy. And actually, before I do that, let me go back to my lists. And right here, I've got a chat apps application list here. And if we were to come in here and edit this, you can see that I've got some applications here. I'm actually going to go delete this real quick just so you guys can see how this works. And I'm going to go ahead and delete it. Yep. There we go. And then I'm going to go back over here to custom options and then traffic policy, because this is a traffic policy. I'm going to come in here and I'm going to add and create a new policy. So I'm going to be basically adding a new policy under this one. So let's say you've already got something, right? And then you need to add to it. This is how you would do that. So I'm going to click in here, create new. I'm going to call this AAR-chat apps. Copy and paste this in. I'm going to add a sequence rule. And instead of calling the protocol and the destination port like we did for layer 4 inspection, we're going to use deep packet inspection. I'm going to come over here, and in here we have a couple of them. Where we have Google, we have Microsoft. I'm going to create one here. I'm going to call this chat apps, and then application. I'm going to come in, and then now it's a little tricky here. You don't click right where I'm clicking right here. You click down here in the search bar. I don't know why they did this, but okay. If you come in here and type in AOL, you'll get AOL Messenger. If you do, I looked up Slack. Slack doesn't show up here, which I thought was a little surprising. If you look in here and you do like WhatsApp, that's in there as well. And then we'll go ahead and we'll do, if you type in just chat, you get a couple of other ones. We'll go ahead and type in Google Chat just to make it a little bit different than I had before. And then we're going to click on save, right? And now now that I've got that in play, I have to actually select it. So chat apps. And then in the actions, we have to create the SLA class list. Now if we come in here, there is nothing here. Right? We have telnet, but I'm not going to use that one. I'm actually going to come in here. I'm going to create a new SLA class list. I'm going to call this chat apps, and the packet loss we'll say is 30%. Latency will be 250, and then jitter will be 300. Click on save, and then that we'll go ahead and grab that one. And the preferred color here we'll say is going to be public internet. We'll click on that, and we're going to click on strict, where we're saying regardless of what happens, if these applications that are listed here are really, really bad, then public internet is the only transport we're going to give them, but we're not going to allow you to fail over to MPLS. Maybe MPLS doesn't have any type of internet connectivity, so we're going to go ahead and do that. Click Save, Match, and Continue, and I'm going to save Application Aware Routing Policy, and then I'm going to go to the centralized policy, and if I click underneath here and I look at the view and click AAR, it's not here, right? So I have to go back underneath my traffic policy and underneath traffic data, application aware routing, I have to add that policy. Because even though if I was to come underneath here and say edit, right? Even though I've created it, I haven't actually added it here. So I need to click in here and, I'm sorry, not that. Go underneath traffic rules, and then I need to go underneath AAR. I need to import existing, and then click in here and go chat apps. Click on import. Now that adds it. I'm going to go ahead and save policy changes, and now it's going to activate with that. Before I do that though, let me go back over here to network, and then we're going to grab VH3 under troubleshooting, so you can see the before and after, right? And then I'm going to choose VPN1, and then this destination 10.1.0.16, and then the application, we can go specifically in here and look at, say, for example, AOL Messenger. And I'm going to simulate flow. And it's going to use both, right? Because it can, which is what I want it to do, right? I want it to be able to use both if I can. Equal cost multipath. Now if I go back over here to policies, and I go to the edit here, and I go to traffic rules, and I add a policy, import existing, grab, chat apps, and click on import, and then save policy changes, and then activate. Sorry, what? Activate, no. Add VPN list. Oh, okay. Policy application aware routing. Oh, that's right, I forgot, I have to add. We'll go VH4, that's my mistake. And then VPN list, we'll go add that. So you still have to, when you're in the editing of the policy, if you've added one, you still have to go underneath here and map it to wherever it's going to be applied to. Click on add, save policy changes, and then activate. Interesting. Okay, so simply failed, duplicate mapping detected. Interesting. Okay. Huh. Okay, well, I'll just delete this one and save policy changes. Let me go back over here to traffic rules, and then underneath this one here, I will detach this one, save policy changes. There it goes. All right, so normally you wouldn't do that, but because of the fact that we're just testing this and I'm just showing you how it would work, it's not going to hurt anything if it's not there. So there we go. So we're gonna wait for it to push, and then once it's done doing that, there we go. So we're gonna come back over here to monitor and network VH3, underneath troubleshooting, simulate flows, VPN1, choose the interface, and then 10.1.0.16, and then the application we're going to choose is going to be AOL Messenger, simulate flow, and now it only takes public internet. So that, ladies and gentlemen, is application aware routing. It's not very complicated, as you can see. Pretty straightforward stuff. There are ways to add in a policy, but in this case here, it gave me a problem with it, so I was like, okay, fine, whatever, it's a lab, I really don't care. But if you need to add that into something, obviously you'd want to make sure you do that correctly and test it out before you actually go push. So, but that's pretty much it for application aware routing. I want to thank you guys for hanging out with me in this video, and until next time, guys, take it easy.